Hello, welcome to my YouTube channel Data Partnership. So today I will show you how to delineate a catchment area of a flat area. If you have flat terrain, it's sometimes it's very complicated to delineate catchment of any river basin, right? So so I thought that this will be an important topic, and many people maybe having issues to delineate during the delineation of catchment. So I have taken one sample area which is in somewhere southern part of India. So it's a south of various. I have taken this river, a small portion of this river. So it is south of Kalidam River here, right? So it is just an sample, so that you can do it for your study area. So in my previous videos also, I have shown you how to download the digital elevation model through Google Earth Engine or through the QGIS. So what I will do is I will show you both the method how to download it again, and then I will do the delineation process, so that it will be a complete package of how to delineate a catchment. So first we will do by Google Earth Engine. Just Google type here and Google Earth Engine. So Google Earth Engine, yes, we will it will open like this, and no, I have Google Earth Engine. Yes, Google Earth Engine. Then I will go to platform, code editor. Then you need Gmail for the same. So I will um, use my Gmail, and it will open like this. So basically, I have separate video for this. So I have already done the code. So I will just show you how to do it for your study area. So my study area is in India, right? So I just showed you in here in my Google Earth that it is south of Kalidam River. So we need a location for that. Same, it's an Chidambaram place, one of the place north of this river. So what I will do is I will just type here Kalidam, right? Kalidam River, Kalidam, yeah, Kalidam, Kalidam River, right? Just why I'm writing, we are writing here is because I need to search where my area is, right? So that it will be easy for you to identify the area. So it is somewhere here. So this is Kalidam River. So this this should be my river. This one, right? I have delineated this one. So, there are. I told you that that there are many ways to do. First is that I have to just I will select this geometry. I will create uh, geometry for this area, something like this. Oh no, sorry. I will just delete it here. Yeah, before that, I what I will do is I have one already have this mm, code for this. Only thing is that I have written this code. I already showed this one, but just to give you an confidence, that's why I'm doing this again. So only thing is that this code will be similar for all. Only thing is that the geometry will change. So I will just delete it. I will add new geometry, right? So my study area is somewhere here. So I will just it up to you. So I have taken this area, right? Just click here. So this geometry will be updated here, right? The rest of the code will be similar. This is a USGS starting 30-meter DEM. I have, I'm going to download. Just run it because everything will be same. Then we'll go to task here. Then I will run it. So it will ask you the task name. What will be your file name is? My file name is DM test, whatever. Yeah, and run it. So scale is the 30-meter resolution. So it may take some time uh, to download. So up to that time, what I will do is we can do. in QGIS also, how to download it, QGIS. I told you earlier that we have a plugin called SRTM downloader. You just install this SRTM downloader here and then click here. So before doing this, what you do is you just add the Google image here, Google satellite, yeah, Google satellite here, right? And you also add, I have a save file of that stream, which I'm going to show you, this one, and this is stream, right? Yeah. No, why? What happened? Yeah, but that is too long. Why? It's not too long. Yeah. So this is my river here, right? So I need download the DM for this. So if I go to plugin SRTM downloader, so just set canvas extend, means whatever I have opened, it will download for that area. You just go to output path, the same folder. I will go here and I will say DM test. Yeah, right. So download. So while downloading, it will ask you the user ID password. So here is a link in blue color. You open it and you just register yourself, so that you know. So I have already registered, so I will not do that for again, right? So okay, so it may take some time. It should be very quickly. Yeah. So up to that time, you will see while this one it's done, right? So we can see here, in the Google, in my Google Drive. What I will do is I will go here. My Google Drive is here somewhere. Um, yeah, so I will go to my Google Drive. Right, you can see DM test, right? So just I will download from here. Yeah, yeah. So it's a downloaded, right? Download come, and this one also the completed. So now what happened is uh, this we have downloaded from yeah, through QGIS by using SRTM downloader. So you can see our study area is somewhere here, but it downloaded the whole tile, means the data is stored in tiles, right? So when I tried to download for this area, but it downloaded whole tiles, right? So, we need to process this whole tile before doing this, or we have to clip something. So we need to do additional step. But if you see that the download which we have downloaded through Google Earth Engine, this DM test, right? If you see, so it downloaded for this area only, right? So you can see the difference. So in Google Earth Engine, you can download for your selected area. If you have save file for your study area, then you upload that save file in Google Earth Engine. You can extract DM for that area only. But here what we have done is we have done for this area, right? Or we can take the bigger area, so that you know it can helpful if your catchment is going it's bigger than what you are expecting, then it will easy to manipulate the things, right? So that's why this is the one of the difference, right? So what I will do is next is that this DM we will use this DM test, because it's a small thing, small DM, so that you know it will help us to process early, clearly. So what I will do is first is the projection system. So what is the projection system? Is the units are in degrees. We will convert it into meters. So we'll go to raster. We will do projection, reproject, dream test. You just 40. It's a 44 north, right? It's a 44 north. So how to know the 44th north? If you go open the Google Earth, right? this, and you can see here you can see 44p. 44p means it's a 44 north. So for that, your unit should be in meter. How you can see the meter? Tools, go to options. You have to select universe transfer marketer, and your unit of measurement should be meter and kilometer, right? So it's a 44 north. So what I will do, I will go to raster projection reproject, right? I will select from here 44 north, right? And save. So I have already done here. So I will just overwrite it. UTM-DM, right? Done. Run. So now you can see our units will be in meter. Yeah, you can see meter, and you go down. Then WG34, UTM zone 44 units in meter and projected. Right? Now I will just delete this one because now we will use this. So what will be our next step is, since suppose we first will fill it this DU. So this is a general process. General process is that why first you have to fill, then calculate the flow direction or flow accumulation, then create the um, catchment area. So what I will do, how I will do is that I will fill this one. Just type here fill. So you will see that since we are using grass, so r dot fill dot dir. So this is UTM thing, and our depressionless DM will be this one is filled DM, filled them, right? So just uncheck those things. Yeah, so it may take some time. Yeah, it's done, right? So we have now, I will delete this one also. Now our DM will be filled DM, right? This we will use for everything. Or we will use that one also, but maybe it required another method which I am going to use. But right now it's a UTM DM. So but we are what we are using going to use it, this fill DM, right? This one. So what next is that fill dot watershed. There is no, sorry, R dot watershed. So we have this R dot watershed. Click here. Elevation will be filled EM. Just these are the options. Just and this maximum size you just put it 50 kilometer, means it will take the area of 50 square kilometer, so that it will extract the things those streams from 50 square kilometer. You can take 100 also. It depends on the how big that area is. So just enable this one, and first is that number of cells that drains into each cell is flow accumulation. This flow accumulation, and this one your drainage direction is flow direction, right? Yes, and just uncheck those things because these are the required for some other purposes, right? And just run it. Yeah. So we have run. This is flow accumulation. This is flow direction. So guys, what happen is if you zoom here and our stream, you up, up- just overlay this our stream channel, right? So you can see our, of course, this is, you can see there are gaps actually, right? This our there is no connection between these angles, right? It means there is some not a problem, but the area is like that because the direction, the flow direction accumulation is happening this way and this way, from there this way, and from here this way. So if you do the thing, but your stream is clearly shown that it is coming like this existing stream, and if you see the flow direction, then there is, there is no similar pattern. So what why it is happening is that our values are in flow direction in -8 to 8, whether so it should be 1 to 8. So what we will do is that we will take the absolute values of flow direction. So what I will do is I will go to raster calculator, ABS absolute. There is this. You just write this one. ABS mean absolute, and absolute value of flow direction. So what I will do here, there is flow direction ABS. I already did that or not? No, right? So what I will do, FDR run it. I think I have done something wrong. I will just remove it. I will do it again. So what I will do is I will go to raster calculator with absolute of FDR. This one, and output layer will be uh, FDR ABS, right? And our UTM coordinate system will be 44 knots. Sometime it happens. It should not happen, but I don't know why. Okay. So you can see it is not coming in that way what I was expecting. Okay. Why it is happening is, just let's check the, so why it should come like, right. So what I will do, ABS, let me check 44 of FTR1, right? Sometime the output is FTR ABS, yes, and this should be 44, and why it is not happening is, yeah, so it happens, right? Now we have values in 1 to 8. So if you see, if you put this one, so here is no clear sign. Here you can see the better flow direction, but here you can see there is something. There is here the system is different. Here direction is different, right? But our river is flow like this. This may happen, but it will not help you to to, because what will happen is, if you delineate catchment at this point where my cursor is, then your catchment will be like this, downward side, and it should be upward side. But still, it is not. It may happen, but you need to know the process, right? So what I will do is then, and this flow direction also, things are not connecting, and your our accumulation is like that. Our catchment will come like this, in this way, right? So what I will do is, and then the steam burning things will come into picture. I will just remove this one, so that now we'll do the another method. This one remove, and these things will be same. So what I will do is, there is called Carve, R dot Carve. One tool is R dot Carve. Here you can do the fill DM, you can do the stream, and here I need to put the 0.5, means how much difference should be in your, I mean, because we are just lowering down the depth of river, because since right now what happen is, river length and then the elevation surrounding area will be same, right? Or maybe the surrounding area value is greater than this. So to avoid that, so that then it will create a corridor, right? To do that, I'm putting 0.5. So it is just simple standard thing is that if area is flat, then you have to put the values from 0.5 to 1 to 3. If you are not flat, then you can put more values, 3 to 5, 5 to 10, like that, right? So here you can save it, and I will say that this is modified, right? Just modified the run. So now we have this modified DA. You can say here, we can see that our stream, whether it is coming here or not. Now we have to check, right? You can see if you remove this. So there is one is, because I did not put much value. So you can see we cannot see the river here. So it means we need to put more values there, right? So what I will do, R dot curve that it's a full DM, and we will tell that 1, right? So what I will do is then modify it. So we need to hit and trial also, right? So once it's done, yeah. So now it is also not coming. Oh, why it is not coming? Okay, let me check. Yeah, everything is fine. Coordinate system is fine. So you can see here, we cannot see any stream here, right? Yeah, no, modified, yes. So we cannot see the things, right? So what I will do, then I will again move into, I will do one more chance, build DM stream, it's a one I will do 2 meter, right? And then go save it here, modify, yes, and should come. Okay, there is some problem actually. What happened is, I need to check the uh, this one coordinate system of this. So what happened is this is WGS84 and our field EM is this one WGS 44. So this is very important thing needs to know. So how to do that? We will go to vector. We will go to data management tool, the project layer. Then we have to this one, right? Save it to file. Oh yeah, I have already done that, but again, I'm just showing so that it will help you. All right, done. So that's why it's not coming. Otherwise, you can see easily here. So I will just delete it. So that's why this coordinate reference system is very important. The star dot curve, elevation, field EM, UTM stream. Let's say you can say 1 meter or you can put zero point 0.5 also. You just take care by US. You can take care of that. Yes. And then run. I am here to my thing that at least you should understand the process. So you can see now. We can clearly see the things here, right? Yeah, this one. So so that now we can clearly see that this is the stream. You can see in the Google satellite also, right? This one, yeah, right? So these are the processes to verify the thing. So now again what I will do is then r dot watershed. Now we can do the process the things. Elevation is our modified DM now. This is our DM now. Things maximum size you can 50, 20 because it's a small area, so I will put 10, right? Otherwise, I will take 20 if it is a bigger basin, Ganga or Yamuna or Brahmaputra, then it should be thousand or five more than thousand, 5,000 like that. So rest of the things will be optional, should be the same. Now save, oh sorry, save file will be this of flow accumulation. This one is drainage flow direction, right? Yes, and I we will uncheck these things. Yeah, and run it. Done. So you can see this is I will just I will put it there, right? You see the flow accumulation. Now you can see a connections here, right? This one. And you can see here, this one is, this drainage is connected like this also. So this is very useful thing. And then if you see the flow direction, now you can see our flow direction is very clear here, right? This area is very clear, and here you can say there is a some back gap actually break something break here, so that the things have been changed. The texture is different. Here it's the same. So it means the flow direction is from this side and this way in that side. It all depends where is your point. So point is there, right? So that's why it's a 1 to, it should be 1 to 8, right? So more wherever the black area is means this is the 8 means the direction is this side, right? And this one is direction is this way in this that's why. So here we can see the -8 to 8, so we'll make the negative value into positive so that we will take the absolute values. What how we'll do, we'll go to raster calculator, abs, and then flow direction, yeah, and we will write here we are abs, right? Yes, and run. So now this is the flow. You can see here, we can see the string very clearly, but here different way. So it means things will go this side, things will go this side. So now we can, and also if you want to see the if you want to see the things, means you want to extract the stream, then you can do how r dot water dot extract, right? Extract. You can write here something called extract, right? So it is like that, the r dot stream dot extract. So you can check by yourself. I will give you that, you will take care of. I have, please refer my earlier video. It is not required here, but you can do by yourself. It's your exercise. If not, you are unable to do that, I will help you, right? So it's a very simple, the accumulation, this flow accumulation, that it is not required, it's optional, right? You just minimum flow accumulation of this, it's a, you can like 10, 20, whatever, right? And then these are the optional. Then unique, it's a, you can just uncheck it. Unique stream ds means vector, means you can you can save here, means it will give you the shape file, right? You can write something shape file here. So how you will do is that I can tell you. This is it is very elevation map. Means it's a field DM. Means field DM here is modified one, right? We have modified one because we have burned the image. So modified one and flow accumulation will be this, right? And if you type a 10 or 20, because it's a small area, so the rest thing will be similar. So here you can see the vector is save files, and you can say stream extract whatever, right? And uncheck the other things, right? The folders and everything, then run it, then you will get the uh, stream for those, this area, right? Close. So you can see there is the, okay, we will do it again. So go to, so remove, then extract, right? Elevation map is modified, this one is low accumulation, this is 20, whatever, right? You just uncheck it. Vector means you just write here. mm, I can say this one is 211, right? This one, and run it. Yeah. So so what happened is I have done something wrong here. What happened? I should have taken line feature, right? But I did not do that. So what I will do is, this one is the modified DEM. This one is low accumulation, right? It's 20, right? Or 20 is fine because area is small. So you just write here vector optional, right? You just put it here, stream on GKPG, yes, and it should be right. So I think, yeah. Oh, sorry. Before that, I have to do something else, right? So what I will do is, I will do. I think this is fine. So this one is this one should be the right way to do that. So sorry, I'm confused here. So input map is this one, right? Flow modify D, right? And input flow accumulation is just the 20. Okay, so yeah. So advanced, you can see auto type is line, right? Sometimes very important to do that. So string DQ, or you can say save file also, or you can put save file also. So yes, and go to run. So now it will happen. Yeah. So you can see now we have generated this one, right? This one. Yeah. So you can just export them into save file, history save file, right? Whatever. It's you can save here somewhere here. Means you can do it whatever. You can say like this. Right? It all depends. So you can see the things. You can hit enter. I have taken 20 kilometers square kilometer. You can take more. So it will give you the this thing also. Yeah, this streams, right? So you can do that. So now what I will do is I will now you will uh, delineate the uh, catchment. So R dot water dot outlet. Please remember those things. See my video properly. So drainage direction is flow direction, ABS one, right? So now what will happen is I will ABS and flow accumulation is required here, right? So this is uh, our stream is this one, right? Where we are planning to delineate. Suppose I want to delineate at this point, right? So what I will do is I will go here. Here is flow direction ABS, and then this one is so you can see here one is that our this one is 3857. So it should be similar to our flow direction. So our flow direction thinks how much what it is. It is WGS 84, right? Rome 44 north. So similarly, I have to change it. So what is our 44 north? This one, select this so that it will take the value from there. So R dot water dot outlet, I will go to this one and then click here, and then I will just zoom in and I will click here, right? So it will take the EPHE, the same coordinate system. At this is the 4 point location, right? So just I will type, just I will see the basin, yeah, and then run. So you can see, yeah, so it came here, right? So you can see this is our basin. So you can, so now it's a raster. So all depends. If you take this one, it will give you like that. This one, so you can try that. So this is our catchment area. So now since it's a raster, so we have to take to make it vector. So raster images, then how I will do is that conversion. Conversion means polygonize raster to vector. So I will say this is the basin. Bn, I will just write here basin, catchment area, whatever. Catchment area. It's a save file. It should be save file, right? The save file. You can take the save file also. Catchment area. Yeah, and run it. Yeah. So you have this catchment area. This is your you have stream there. So these are the streams here. So you can see you can you just off them this one. So this is your stream. So you can clip those or go to here your processing tool. You can clip with the files here. Catchment area overlay layer is your streams. No streams. What are they? uh, this stream updated, go to vector and clip. These are the streams updated. Overlay is catchment area. So stream in your catchment, right? Yes. Yeah. So these are your streams. So you can create the you can yeah just simplify it. Simple line, black, whatever, right? And you can put those files into this one. Yeah. Apply. Yeah. So you can accordingly you can create layout, go to layout, go to create and anything means test, right? Click here, then go here this way and select here, and you can zoom in whatever 33, you can make it 30, yeah, you can 25, you have to play with this, right? Or 20, 20,000, 20,000, yeah, 20, yes. So something like this, yeah. So you just adjust the things here and there, right? So this is your thing, and you can put this grid, yeah, grid, modify, and this is showing in this one. Uh, you can let long also, WGS80 for whatever, and you can say one. This is one. Since it's a you know it's a very small area, so that's why it is coming like that. You can see here, grid, modify. So it is 0.5. No, let's see. All right, and this is something two. No, then it will be one, one. So this is a grid, and you can you means this is the because our unit is like that, right? Otherwise, if it is bigger area, then more grids will come up here, right? And then you can frame something, yeah, it's a zebra thing, or no frame, and you can draw the coordinates, yeah, you can draw the coordinate. If it is horizontal, the vertical, left side and right side. Right side also it should be vertical, then this will come up, right? Because it's a very small area, so that's why it is coming like the way this way. And you can put the legend, add item. You can put the legend here. You just type here. So you go here, just remove the other things what you don't need. Just remove from here. Only thing what you need is just remove this one also, right? Catchment area and streams, right? Yeah, just remove here. This, yeah, only what you need is catchment area and these streams. You need this one, right? You just type a legend. Yes, legend will come like if you add more features, then it will come like this and add scale bar because scale is very that's why it is coming. Our grid this is coming in one grid and less than one grid and go to north arrow. Just put the north arrow here. It will be big thing. Yeah, you just put it here. Take the small size for better look. You just what you do is you just uh, put one frame here. This frame is coming like this, and you can type here or something. Your Kalidam river catchment, whatever. I'm just standing. I don't know what is the catchment name, but catchment. Just go here and just click here font. Yeah, it's bold. You can say the 16. Adjust it like this way, right? And just go layout and export. And this is your yeah test whatever. Save here. Then you click here. Will come like this. So this is your catchment area. And you can put this you can put this in your report or wherever in your presentation. So what I will do is just adjust this thing here since it is where going outside. So you can put like this or you can put scale here also and legend this way. Because now you have to beautify the things. You know how to do that because this is you do like this because you need to adjust the thing. Just click here, then you can put this way. Now it is coming like, yeah, right? So guys, this is what I wanted to show you, right? I think it's very interesting for you guys. Please do this by yourself. Take any study area. Um, Stream burning is important thing here. So you uh, take your study area and do practice, right? Thank you very much. Thank you. Please subscribe my channel.